Hello and welcome back to Stationeers. I'm Rob and today we're back here in our testing facility on Mars. Today we are looking into what is in front of us, which is an IC housing with an IC chip. We are going to dive into what it is, how you get into using it, how you can actually integrate with it, and how to learn about it. We're not going to particularly code today, but we're going to do very rough things in the coding. This is for an introduction into the IC circuit. So if you don't really have any idea of how to get started, this might be a suitable place to look and to learn about it. So without further ado, let's dive in. So to get started, first of all, you need these two things in front of us. You have the house itself, which is the holder of the chip. Then you have the chip, which is the brain of the thing. In the PC, that'll be the CPU. This little thing, the house, will cost you 10 copper, 4 steel, and 2 solder. The chip itself is 10 gold, 4 steel, 5 electrum, and 2 solder. So not crazy expensive, but not crazy cheap either. Benefits of where you want to use this: if you want to make it more advanced in terms of programming, then this one comes in handy. It only takes 50 watt. So if you're doing more logic chips, like you see here, we could have one here, but then we're here and here, then it will quickly go above the 50. Now, to build them, you take your house and your chip, pop onto the wall, and there you can see we have a data and a power. And we need both. It can come for 2 separate directions, of course, but normally you pop it onto the wall, pop the chip in like this, and that's it. Then you take your cable and just route the cable around. So we're going to do here, we're going to do a quick junction, turn up, and like this, and like that. So now the power and the data is connected to it. We can turn them on. And as you can see, no error. It's not blinking yellow, which it would be doing if it was in error, and then there will be an error text here. So an IC chip has 6 pins, D0 to D5, where you can actually attach a device to. So let's say you want to look at this analyzer. You want to look at this. So you can actually take your tool, your screwdriver, and select the cable analyzer. Like this. Then everything on this analyzer can be accessed from within this IC chip. So you take a tablet, you have the chip in called configuration, and then you can hold on the actual device. You can see the logic and you can see the actual thing you can read. So here in this fact, you can read power actual, power required, stuff like that. You can also access it from Stationeers. So we type in cable analyzer and find the correct one. Then you can see these ones again. So if they're saying in here read, that means, as you might understand, you can only read them. You cannot write to them. Of course, a analyzer you will not be able to write to anyway. But if it was, let's say, a door. Let's just take this one. You can see here you can read the power. You can read and write the log state, and the power and so on. You can read and write whatever. Like the open state, you can read to. So you have to say open or not. The mode you can read to, and it's quite easy to do in terms of that. But how do you actually handle it? How do you program it? How do you get started to it? Well, you have 2 options. You have the laptop, you have the computer. The computer is very nice when it's something that's not moving, obviously. If you have a test facility, if you have a test lab, if you have a station, if you have a room with a lot of IC chips and you may want to tweak them, then you put in a computer. If you have several IC chips spread on the entire base, then you do a tablet. Tablet is by far the one I prefer the most to have. It requires, of course, a battery, so you can turn it on, and it requires an IC editor motherboard, which is made in which is created, let's just pop it down again, which is created in the electronic printer. So now you can see we have integrated circuit editor, and on this main computer you have again the IC editor motherboard. Pop them in, close that one, so you don't need to open that again. This one has to be connected with power and data, but then when you power it up you can actually see the housing. So if you have multiple IC chips, you can be able to select them here. So if we did name this one, let's say our first IC code, then you can see here this one. Let's just, you can now see that you can actually see this particular chip. For the tablet you would have to take it out, pop it over there. Now it's showing an error because the chip is here, but now you can import from it and you can do whatever. So that is the difference between a laptop and a computer. You're gonna leave the computer here, the laptop here for now, because you might as well do the PC, the computer itself. Now, as you saw before, I could easily mount the cable answer to D0. The D0 is still just named D0. There's no actual tag on any of these, so it doesn't have any syntax for us to explain this D0 is the cable analyzer. Now, if you import first of all, then you know you have what's on this chip because this is what they selected. So import first of all the time import first. You click edit. When you have this picture open and you know you're going to be in here a while, click on this pause button here. What it does, you can also hear that, it pauses the game literally. You do not use food or water or anything like that. Power, nothing goes on. It has some benefits, it also has some side effects. Benefits is you can be in here forever. The side effect is that you cannot search in this thing here. So if I search BRN, nothing would happen. If I move this one, you see it changed straight away. So that is a side effect. That is something you have to remember. If you're trying to search, you have to think, oh, it's not working because it's paused. Keep that in mind. In this window, we are going to do all our coding. We have a total of 128 lines, including the line 0. So line 0 all the way down to line 127. We can have roughly around 52 characters long. You would never go that far anyway, but you can have quite a lot of lines, and there is a maximum of 13,566 bytes in size of this chip. So if I write here, let's say, if I do a hash, which is for a comment, and say this is our new code. Now I've made our first line just saying what it is, and if you didn't click confirm, then it will actually soon take space over here, but you see now it's still saying 0 bytes, so the integrated circuit is at 0 bytes. And that is because the code that we made, you can see here, is not over there yet. To put it over here, you have to click on the export. Now you see we have taken 36 bytes. If it reaches the 13,566 bytes, it will go into error. But that's also a lot of space. Now, let's go back in here and have a look. Good things to know in here. So, the buttons up here. Library. Let's take that one first. That's the bread and butter. So let's say you make a code that is super. You can do anything with it. Then you create a holder. Let's say you just created our new code. So you say, this is my new fantastic stick code. Then you can actually comment to it. What do you think? And if you click confirm here, then you have up here a new holder and a new save file that's called this is my new fantastic code. If you then click on this arrow here, it's basically that you're saving it to the file from your online going here. So if you, let's say, click on this one, it will overwrite the instructions. You confirm you want to overwrite. You then clear, say, oh, that was a mistake. I cleared it by mistake. Then you can always click here again, and it comes back. So it's a good way to keep your storage. Also, if you made it so good that you can actually use it, you like to give away to other people, then if you click on the Steam icon, it will launch onto the Steam workshop, and other people might be able to use it for something. As you can see here, if you go down, I have some codes that I'm borrowing from other designers, from other players who had designed codes that I'm like, oh, I might use this, or I might be able to see what this is. Like from my Let's Play series, I've used this guy, fantastic code, I like to say, and I borrowed his code from the stock workshop. So this tool is very good for that. Of course, you can also delete it if you don't need it anymore. Great. Now the next three: clear, copy, and paste. That makes sense. If you clear, you empty the entire file. If you copy whatever is in your clipboard into this. So on your main computer, on your actual physical computer, you can take a code out, put it into Notepad, for example, and you can tweak around. It will be easier to operate because this in here is Stationeers sort of UI. It's a bit funky sometimes. So if you have to adjust something, it's quicker in the Notepad on your normal computer. Then you can Control-C that, so you can copy that, and you can paste it in, so you can actually copy it into this window here. So those three are quite, they are still explanatory, and they're quite nice. Now, the next thing is transparent, non-transparent. Never used it. Why would you make the code harder to read than it already is? It makes no sense to me. I particularly don't like to use this one. Now we have these three out here, and these three are your library. It's your function library, like in Excel or in other coding programs. You have a library where you can find ideas about what to do. So the first one is a slot variable. So everything on a device that's a slot, you can read from these. You might be able to read these things, like occupied. If the slot 0 on a furnace is occupied, you can read the occupied state of the slot. You can read the occupant hash, you can read the quantity, and so on and so on. These names, so quantity or damage, these are exact names. So if you're referring to damage, you have to write this exact. You cannot write damage with a small d. That won't work. You have to write exact. But it's a good guidance for you to find exactly what you're looking for on, let's say, a battery or a temperature from a sensor or something. It's quite nice to do that. So if you go back here to our to this one, these are those type of things. This is the logic ones, but these are still. Do we have a slot here? We have a slot here. Let's take a recycler. Then I can show what I mean by slot. Recycler. There. So here are the slots I'm talking about. So we have slot 1 and 0, or 0 and 1. And you have occupied, you have class, your occupant has. These are the ones that I was showing you before you can read. They're not the same on all of them, but you can use that as a guide to find what you need to look at. Now the next one, the X, is the variable. This is the one where you find most things inside. So like open, you find it here. So you can in here you can find all the variables that you want to activate in the logic. So these are basically also what you are looking at when you do normal chip coding, to open a door, to activate something. It's in here they're located. Normally you won't use these two. I personally don't. I look at the device I'm trying to handle because I can see what they can do. So if I think, they might have an open, they might not have an open actually, but I think they have an open. So go look at the device. My personal way of doing it is I want to control this one, right? So I find this one on the Stationepedia. I see what do we have on logic and what do we have on logic slots, and so on, and then I go from that. So next thing, and this is the really important one, the functions. The functions is where all your code is. I'm not going to go through everything because there's a lot. Some I don't use, some I use. But like here, you see that the one that's probably used most times is a yield, pauses execution for one tick. And when you write yield, and you write it exactly as it says here, that is what it will be doing. You also have the sub. You have the sub, which is the two values minus each other. You have add, subtract, not subtract, multiply, and so on and so on. They are all in here. Now, if let's say you want to find something and when you start to get the grasp around things, you can actually see a certain pattern. So S normally means something with Z. So if you do S, the basic S, which is here, then you store a value somewhere, and then you again here SAP is the same thing, but then it's more complicated things. So when you get the hang around things and you start to know how things are, you can start to search for things. Let's say you know you have something called BRNE maybe, and you see, okay, so these are sort of what you want to see, but not exactly. You will then see a small explanatory text saying what it is. So when you have starting to remember the different functions, some of them you might use a lot, and you search for them, you will see the explanatory text of what it kind of do or what it actually is doing, and then you'll see what to put where. So like here, brands, relative brands to line C if A is not equal to B. So if you go in here, type BRNE, then you get the same things, and you can even hold over the BRNE, the syntax of the function. Then you can see exactly what you have to do. And that is, and then from there, it's up to you to decide what you do. So that's a bit about the overall layout here. Now the cancel and the confirm obviously makes sense. I would never use cancel because why? Unless I know I've made a mistake in the program. But confirm is definitely one thing you have to remember. You cannot close, otherwise you'll forget. Now as you can see here, the size and the 4096 bytes compared to this doesn't match up. I don't know why this is not the same. Could be a mistake, could not be a mistake. It could, who knows? So now that we have gone through these two, the UI and the functionality of the UI, we'll do a bit of basic starting up code. So first of all, inside the UI of the laptop, it's the same, identical, 100% identical. So yeah, that is good. Now, regarding this one, what if we decided to code the power consumption, like I said, the actual power consumption here, and get it over here, for example. Now, we have, as I said, the 6 buttons, the 6 pins for connecting parts to, but we have a 7th one. And you can see that is a state. That state can have information. It can have either, like say, a boolean, so a 0 and a 1, or some sort of an integer, like power. We can also name this one so it actually fits with some sort of syntax in our head that we actually make sense, like cable analyzer, for example. So what do? We go into the computer and we make that look correct. First thing we're going to type in here is alias. Now, alias is basically to label a device or register with a name so we can understand it a bit better. Because, so we have the cable analyzer sitting on D0. D0 is fine. We could use the D0 if we wanted to, but it's not really easy to understand that D0 is a cable analyzer. Now, we will then say cable analyzer, is that how I spell it? I think so, and put that on D0. That means that we're now saying that D0 is equal to cable analyzer. Okay, good. So we put that in here, you see it's right there. We export that, still not an error. Go here, and now it says cable analyzer, cable analyzer. What do you want to see? Lovely, it's very good. That means that the actual pin is now called the same thing, without the space. Now, we also want to reference the actual house. Now the house, instead of D0, is called DB. We can also alias that. So let's say IC house DB. This you wouldn't do. I mean, most people wouldn't do it. First of all, no, this I personally wouldn't do. I wouldn't alias the IC house because first of all, I know the DB can only be the IC house. Secondly, it's taking a line, and the line in the IC chip is very precious. So I would delete that. Now we can keep it for now. So alias IC house DB. Copy that, confirm that, copy it out. And let's see, it looks okay. So bear in mind, this line is not necessary. None of these lines are necessary to have. This one in particular is unnecessary, it's more waste. This one is nice to have to locate what it is. So now what we want to do is we want to read the power supply from this one, the power consumption. So the 310. Yeah, we want to read the 310 on this one. So there was a state 0. We want to read that as 310 or 300, whatever. It'll be a constant changing effect. Now, if we make a register, because this one is just holding the actual device. It's not holding the power, but it's holding the actual device. We want to have another thing to hold data. So if we say alias power cons or whatever you want to call it, say R0. Now, what is R0? R0 is a numbered memory bit. The IC chip has 16 memory bits or registers, R0 to R15. Each of them can be referred to as R0, R1, R2, R15, whatever you want, or you can alias them as something. It doesn't matter what you call them, it's up to you. It's for your head to understand it the best. Now, next we want to do, now that we have a power consumption here, is we want to read the power actual of this cable analyzer onto the register, and then from the register onto the DB. Okay, so we're going to say L. Now L is loads. So if you go in here and you search for L, you will also find it here. So the same thing. So it says you load. So L is the load. So it's a bit it's doing in the opposite direction of what I would do. But anyway, it's loading onto a register from a device, the D for the device, and then the logic type. If you set ls, it will be a slot index. So which slot, like the input slot or something. But right now it's just the function. Here we could say R0, or we could take the power cons. And we're going to do power cons. There we are. And we're going to do from D0. And we're going to do what it's called. Let's say have a look. It's called power actual. And we're going to type that in here. If we type it correctly, it will change color to orange. Power. If I can spell, that would be lovely. Power actual. Now, that will then give us the value from the cable answer that we just looked at. So 310 roughly. Now that we have this located on here, then we can set the dB, is this one. So set the dB, so we take the house down. And what value do we need to set? Because what is it? Is it just, what do we need? Well, as you see here, we have something called setting. Setting is a very common thing to set. That is the holder of a lot of different things. Let's say we go here. Here you also have setting, which is reading from this one as well. You can read on here. No, this, yeah, setting in. And setting here is the value, the output of this one. So setting is often the setting you're doing, the actual handling of data. So we type in here, setting, again change to orange, and you take the power consumption, put it in. Right now it says 0. Now it says 310. Fantastic. Let's turn off the PC. It still says 310. Should it not change? Yes. See, now that is just gone down from 310 to 110 because that one is quite heavy in power. Why is this one not changing? That's because of the way we have made our code. This code runs top to bottom, and that's it. We need to tell it to go down through the code, whatever length it has, and then all the way back up again to repeat itself. We don't need these up here. That is not necessary because they are constants. They are not changing. They will stay the same. At least these ones will stay the same. What we're going to make is we're going to make a jump point, a place where we can jump to. So if we say start and do those 2 dots, I can't remember there. This means this is now a line name basically. It's a point that we can refer to as start. So the code starts here, goes down through all this, goes past start, do nothing here, reads this one, sets this one, and then continues down. Does not jump back up. Now if you go in here into the functions, and let's say for search for jump, let's say search jump. Oh, J for jump. Jump execution line. Jump execution to line A, and A will be something. We have now named this line 4 to start. So if we go in down here, say jump start. This means it will jump up to this one. And then if this one moves down, it will continue to jump to this one. It doesn't matter which line it is. So we're not referring to the actual line. We could say 4 here, but that would be stupid. So now we are constantly updating this one. So if now that we have transferred it, we're constantly updating it, we can turn off this one and we can see how it changes value. This way we have a simple little code to run. And as you can see back here, I think we have 2. No, we only have 1. Okay. Well, we're technically doing the same thing as this one is doing, because he is reading from that one, but he can also read from that one. So if we turn this one off, and remove him. Let's see here. I just want to show you that you can actually use... Yeah, so now nothing is on the console. But the console, if you put this one in, can read from the first code. Same thing. Ta-da! It is now reading from this one directly, which is lovely. And now you have made your first code and you are starting a whole new journey down the rabbit hole of IC coding. Eventually you'll have your entire wall coded, filled with codes to maximize your effort in this game. I hope you learned a little bit about what to start with, where to go, and we will continue on our journey in IC house coding, IC chip coding next time. Until then, take care everybody. Bye for now.